Okay, Assalamualaikum. Me is Ashikin Mokhtar and my friends Anissa Hazimah and Ashraf Wajri. So for now, we will present about practical project titled Crude Fat Analysis Soxhlet. Soxhlet extraction is one of the most popular techniques for the extraction of analytes from solid materials. So it is a simple and effective method. It has been used for a wide range of samples like soils, sediments, and animal and plant tissues. Soxhlet extraction is one of the most used methods for the determination of total fat. This mainly because it is simple to use and is the officially recognized method for a wide range of fat content determinations. Nowadays, improved extraction techniques tend to be more accurate and more generally applicable and can therefore often replace the old standard method for the official analysis of many food materials. At the end of extraction, the solvent is removed in a step-by-step process, leaving the cups with only extractable matters of fat. The cups are dry and weighed, and the percentage of extractable fats is calculated. So from this project, the objective that we can get is to distinguish between methods used in food analysis and evaluate and making choice of different methods used in food analysis. So and then I will pass this presentation to the next presenter.
I will continue. I will present about procedure. Sample preparation procedure. Instructions are given for analysis in triplicate. The fat content of snack products was recorded as reported on the package label. The size of the serving should also be recorded in order to be able to calculate gram fat per 100 gram of product. 30 gram of the sample was lightly ground with a mortar and pestle. Excessive grinding will cause loss of more fat in the mortar. Plastic gloves were done. 3 pedrite cellulose timbers were removed from the desiccator. The timbers on the outside was labeled with initials and numbers. Use a lead pencil. Then weigh accurately on an analytical balance. A 1 gram sample was weighed using an analytical balance M0, and the sample was packed with filter paper. Short-term procedure. The extraction beaker with 3 to 5 boiling stones was dried for 1 hour at 105 Celsius degree and cooled in the desiccator for 1 hour. That's M1. And the sample was placed in a timber and covered with cotton. Then put it in a beaker. So the formula is percent fat equals to M2 minus M1 times 100 per M0. The short-term program started using SOP. 3 samples were placed in a Soxhlet extractor. After the program, the timber was removed from the extraction beaker using tongs and dry the extraction beaker for 1 hour at 105 degrees Celsius. Cooled in desiccator for 1 hour and weighed M2. So the next is about result. So the sample we use is hard sand biscuit, and replication we use is R1. So M0 in gram we get is 1.0964, and M1 we get 145.1842, and for M2 we get 145.5293, and from the result we can get the fats content percents. So from the formula, 145.5293 minus 145.1842 per 1 0.0964 times 100. So from the formula, and we get the answer is 31.48%. So from the formula, we can compare the nutrition facts from the label in Hubsan biscuit. What are the saturated fat in one biscuit? So that's all from me. Most presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Anissa Hazima from DFE 3A. Today I will continue my presentation with the question. The first question is, the Soxhlet extraction procedure utilized petroleum ether. What were the advantages of using it rather than ethyl ether? So, petroleum ether is made up of pentane and hexane, which is the portion of petroleum with a low boiling point. To compare with the ethyl ether, it is less hygroscopic, more affordable, and less flammable. So because of this, petroleum ether extract do not require drying, whereas ethyl ether extract do. It does have one drawback, though it is more hydrophobic than ethyl ether. Therefore, we choose petroleum ether than ethyl ether. Next question is, what were the advantages of using the Soxhlet extraction method rather than the goldfish extraction method? So what is goldfish extraction method? Goldfish is a continuous method of fat extraction, while Soxhlet is semi-continuous. Although a continuous extraction method is faster than a semi-continuous, the goldfish is susceptible to channeling of the sample during extraction, which will lead to an incomplete extraction. This may occur with Soxhlet and thus potentially underestimating the fat content. So our last question is, if the fat content measured here different from that reported on the nutrition label, how might this be explained? So maybe this is explained with several things that could have led to the disparity. If the technique employed in the lab were comparable to those used to determine the labels information, inadequate protein and carbohydrate hydrolysis, insufficient drying, or improper sample preparation methods can all result in accurate fat content measurements. If the sample particles are too big, the sample contains moisture that hinder the ether's mobility, or the fats are attached to protein or carbohydrates. Non-polar solvents are unable to extract fat effectively. Changes in extraction selectivity and overall fat extraction efficiency will result from a change in the petroleum ether ratio. So the effectiveness of extraction will also be impacted by temperature changes. Finally, rounding the regulation that may cause variations apply to the amount of fat on nutrient label. To make this Soxhlet method, first thing first, we need to know the step by step to do this method. So in order to extract the lipids from foods or the fats from foods using the Soxhlet method, first we must take the sample. So for our experiment, we take 1 gram. First thing first, the sample is first dried, ground into tiny pieces and put in a porous thimble. It primarily consists of a flask, an extracted chamber, and a condenser. A thimble is used to hold the sample. After heating the flask, the solvent evaporates and is transferred up to the condenser, where it is changed into a liquid and collected into the extraction chamber with the sample. The solvent removes the lipid from the sample as it moves, through it and carries them into the flask. So normally this extraction process takes many hours, maybe like 6 or 24 hours. Then the solvent is extinguished when the extraction is finished, and the mass of lipid that is left over is quantified and used for analysis. So when we talk about our experiment, first thing first, we find the MO. What is MO? MO is the 1 gram of our sample. So how do we find our gram? We use analytic balance. So we take 1 gram of our sample, which is half cent. So the reading that we got is 1.0964 gram. So the second step is we find M1. So M1 is wake the extraction beaker with 3 until 5 boiling stones that have been dried for 1 hour at 105 degrees Celsius, cool in a desiccator for 1 hour. So after we do this, we got our MI is 145.1842 gram. After we done the step of found M1, then we found M2. M2 is thimble was removed from the extraction beaker using tweezer and dried in extraction beaker for 1 hour at 105 degrees Celsius, cool in desiccator for 1 hour, and wait. So our group got the reading of M2 was 145.5293 gram. So after we done all the steps, we can obtain the result fat using calculation. So we got our content of the experiment is 31.48% of fat content. If we look at the fat content on the labeling of Hubsank label, we got the total fat is 22%, which is this number is lower than our data experiment. So why this experiment have slightly different or not same as the fat content on the label? After we make a little discussion, so we know that first thing first, our data is not same as displayed on the label. Maybe there are many types of fat as well as variety of ways to test it. So there are few methods to analyze of fat content in professional ways, which is first gas chromatograph method, and second is solvent extraction gravimetric method. Then to testing and analyzing fat in food can be a complex process, so that the data on the food labeling is not 100% accurate. Next, our measurement of nutritional components are said to be accurate to within 2% to 5%. Therefore, a food's nutritional label will deviate slightly from the experimental value. The nutritional information of food label is not always correct. Last but not least, our third reason is maybe some of the fat is not indicated on the label. Although the proportion can be determined, trans fat is not displayed. Trans fat is not listed with saturated fat, which also increases the risk of heart disease. So because of this, trans fat is not listed because it can cause or lead to many of disease, with, for example, risk of heart disease. According to a remark from Witten, he make an experiment which is the crackers label only lists 1 gram of saturated fat, but when Witten sent them to the lab, they discovered the fat have 2 grams of trans fat. so the fat content contains 3 times much unhealthy fat as is shown on the label. Thus, this equation can be used to support our result that there may be a fat in food that are not included on food labels, which is why fat content in our experiment was higher than the fat content in the product labeling.
The conclusion, we can obtain data on the fat of experimental data by using the Soxhlet method on a variety of snack food samples. We may compare the data we obtained to the label for fat that was present in the nutritional labeling. A variety of snack food samples will be processing using the Soxhlet method to certain the sample's lipid or fat content. So our experiment employs the Soxhlet extraction technique to calculate the fat content of a piece of half-cent biscuit. Using the Soxhlet extraction technique, we may determine the weight of the fat in the food sample after the Soxhlet has evaporated. So the formula can determine the fat content of the half-cent biscuits. Our data shows that the fat content of our experiment is 31.48%, while the fat content on the labeling of the half-cent biscuit is 20%. So from that, we can conclude that our experiment's fat content is higher than the fat content of the labeling. Since our fat content is slightly different from the fat content list on food labels for several reasons, the data we obtain is acceptable. The reason is testing and analyzing fat in food can be a complex process. Measurements for nutritional components are said to be accurate to within 2% to until 5%, and some of the fat is not indicated on the label. That's all from us. Thank you.